Hello and welcome to another video brought to you by RouTube. In this video, I will be exploring permutation matrices, which are currently in the Year 12 Unit 4 Matrices module. Now, with this change in study design coming in for next year, there will be no modules, and matrices will be part of the Unit 4 course, which all general maths students will study. Okay, so as I normally do, I'm going to begin with the learning objectives. As you can see, there are a fair few objectives for this video. So firstly, to gain an understanding of what permutation matrices actually are. The second one is to understand when to pre and post multiply by a permutation matrix. The third one is to successfully pre-multiply a matrix by a permutation matrix. The fourth one is to successfully post-multiply a matrix by a permutation matrix. The second last one, the fifth one, is to be able to find the permutation matrix when it's not given. And the final one is to successfully identify how a permutation matrix can also be an identity matrix. Okay, so I thought I'll start just by giving a really brief and basic introduction into permutation matrices and what they actually are. So permutation matrices are square binary matrices that contain a single one in each row and in each column, with the rest of the elements being zeros. Okay, so we know in our prior knowledge that square matrices are matrices that contain the same number of rows and the same number of columns. So for example, a 2 by 2 or a 3 by 3, 4 by 4, and so on. And a binary matrix is a matrix that just contains elements being ones and zeros. Next, a permutation matrix can be used to rearrange the positions of sum/all. So it's either sum or all, and we'll touch on that in a second. So it rearranges the positions of sum/all of the elements in another matrix. So let's have a look at this first example here. So we've got matrix P, matrix Q, and then a matrix R. So if we have a look here, we've got matrix P, which is our permutation matrix, and we know it's a permutation matrix because it satisfies that first sentence that I sort of spoke about, where it's a square matrix, it's a 3 by 3, and it only contains a single one in each row and column, and the rest of the elements being zeros. Okay, so that's a permutation matrix. Next, we've got matrix Q, which is a column matrix because it only contains one column. And then we have the answer of the answer matrix here, which is matrix R. So clearly we can see matrix R is still a column matrix and it's got the same elements. The only difference between matrix Q and matrix R is that two of the elements have changed positions. So the R's gone where the T is and the T's gone where the R is, but the A's stayed the same. Okay. So matrix Q can be pre-multiplied, and once again, we'll have a look at why it must be pre-multiplied by the permutation matrix P to create matrix R. Now, as I said before, matrix R is a rearrangement of matrix Q. And now, once again, not all the elements in matrix Q changed positions. Only the R and the T did, but element A did not change. It remained in the same position, which is totally fine. And now moving along to the second one, once again, we've got the exact same permutation matrix here. Once again, satisfies all the criteria for, to be a permutation matrix. But now we've got a different matrix Q and it looks like a completely different matrix R. Okay, so we've got here matrix Q, which the elements are A, B, C, and then matrix R, the elements are C, B, A. So once again, same elements, just changed in terms of their order. Okay, so the C's gone to where the A was, sorry, the A's gone to where the C was, and the C's gone to where the A was. So the A and the C have swapped, with the B remaining the same. So now we look at matrix Q, can be post-multiplied. Once again, we'll have a look at that deeper as we make our way through the video. So it can be post-multiplied by the permutation matrix P to create matrix R. And once again, matrix R is a rearrangement of matrix Q. And once again, like I said before, the element B in matrix Q didn't move. It stayed the same in the same position, but element A and C sort of swapped positions. So in terms of the mechanics and how the permutation matrix does that, that's obviously what's going to be coming in the rest of the video. But essentially what I want you to take from the last couple of minutes is just that a permutation matrix can either be pre or post multiplied with another matrix to change the positions of some or all of the elements in that particular matrix. Okay, so often when dealing with permutation matrices, you won't be told whether to pre or post multiply, or you sometimes might, but sometimes you won't be told whether to pre or post multiply. You need to work out whether you are going to pre or post multiply. And in some cases, you won't be able to do one or the other, because it's really important that you know when to pre-multiply or when to post-multiply by a permutation matrix. And this part of the video will explain when to do which one. So pre-multiplying by a permutation matrix. So when you need to rearrange the rows in a matrix, you must pre-multiply by a permutation matrix. So that is, when you have a column matrix, a pre-multiplication can only be used to rearrange the elements. Okay, so that's all good and fine. Let's have a look at what it actually looks like. So matrix O, which we can see there, spells the word rand. Now it doesn't need to spell a word, an English word. It could just be 4 random letters put together, but I've just chosen to go with the word rand. So as matrix O is a column matrix, because it consists of one column only, it must be pre-multiplied by a permutation matrix to rearrange the elements. So if you try to post-multiply, which we'll go through in a second, it won't actually work. And again, once again, I'll go through that in a second. So now we move on to post-multiplying by a permutation matrix. So when you need to rearrange the columns now, so we're not rearranging the rows now, we're rearranging the columns. So if you need to rearrange the columns in a matrix, you must post-multiply by a permutation matrix. So that is, when you have a row matrix, a post-multiplication can only be used to rearrange the elements. So you see, everything's sort of the opposite of pre-multiplying. So let's have a look here. Now we've got matrix O, which is pretty much the same as the previous matrix O, although this time the word rand is in a row matrix, not a column matrix. And that changes things sort of dramatically, or it changes things in terms of whether you need to pre or post multiply. So as this matrix O is a row matrix, it must be post multiplied by a permutation matrix to rearrange the elements. Now, like I said before, you need to decide when and which one to use. So you might ask yourself, well, can I just use pre and post multiply whenever I like? And the answer is no. Okay, and we'll see why now. So as we already know, the order of matrices and the order in which we multiply them is extremely important in knowing whether they can or cannot be multiplied. And we talk about defined and undefined. If you're not sure about undefined and defined in terms of multiplying matrices, please feel free to check out my previous video on multiplying matrices and scalar multiplication. So let's have a look. Let's try and post multiply rand as a column matrix here with the permutation matrix, which is here. We know it's a permutation matrix. It's got 1 in every column and every row, with the rest of the elements being a 0, and it's a square binary matrix. Okay, fantastic. So let's try and post multiply rand with that matrix, the permutation matrix. Okay, so the easiest way to do this and see whether you need to pre or post multiply is write out the order of each matrix. So the first column matrix, the order of that is a 4 by 1 because it consists of 4 rows and 1 single column. And then the order of the permutation matrix is a 4 by 4. Now, as we know, hopefully, in terms of your matrix multiplication, the two middle values must be the same in order for the two matrices to be defined, and then we can multiply them. Okay. Now, clearly we can see in this case, these two values are not the same. So the number of columns in the first matrix are not equal to the number of rows in the permutation matrix. So therefore, we cannot multiply. So that means that you have to pre-multiply, which means the permutation matrix has to come first, and then those two middle values will be the same. And then we can also look over on the right hand side. So let's try and pre-multiply rand as a row matrix by the permutation matrix. So if we're pre-multiplying, that means that the permutation matrix is going to come first. So the order of that is going to be 4 by 4, and then the order of rand, this one here that I've just circled as a row matrix, is going to be a 1 by 4. And once again, we can see those middle values being 4 and 1. So the number of columns in the permutation matrix are not equal to the number of rows in that matrix rand, that row matrix. So therefore, that is why we cannot multiply them. So that's a sort of a quick little way for you to see, well, if I pre-multiply or post-multiply, does it actually work? Okay, now in terms of once you work out that you can pre or post multiply depending on the situation, depending whether you've got a row or a column matrix. In terms of the actual multiplication, we'll go through that in the next part of the video, but this is just getting you familiar with when to pre and when to post multiply. All right, let's have a go at pre-multiplying by a permutation matrix. So the question says, apply the permutation matrix by multiplying matrix C and matrix D. Now, if we didn't have the word pre at the top of the page, how would we know whether we need to pre or post multiply? Okay, so obviously we know we need to pre-multiply, but if it didn't say, it just said apply the permutation matrix, you need to decide whether it's pre or post. How would you decide? So once again, we're going to do what we did previously. And let's see, well, I'm going to check to see if I can multiply C with D. So once again, I'm just going to write out the order. So the order of C is a 3 by 1 because there's 3 rows and 1 column. And then the order of matrix D is the square matrix. So I was going to write the word square. Here we go. The order is a 3 by 3. So once again, the two middle numbers are not the same, which means that we cannot multiply them. So it cannot be a post multiplied question. So now we go to the other way and we see DC. So now we rearrange the order and we have matrix D is a 3 by 3 and then matrix C is a 3 by 1. Now we see the two middle numbers are the same, so therefore the order must be D multiplied by C, which means that C is going to be pre-multiplied by the permutation matrix. Okay, so now we know it has to be pre-multiplied. Now you don't have to do that every time, but it's good just to sort of whilst you're beginning and getting the understanding and knowledge of pre and post, that might be a good way for you to do for every few questions, just to sort of make sure you're doing it correctly, because then you might get stuck because you can't actually multiply them. So what we're going to do is we're going to pre-multiply, so it's going to be 0, 1, 0, 0, 0, 1. So I'm just writing out matrix D, and then 1, 0, 0. And then we're going to multiply it by matrix C, which is B, O, L. Now, we need to rearrange some or all of those three elements, so B, O, L. So that's going to change order. Are all three going to move? Well, let's see. So when we are performing or when we're rearranging the rows, which we're doing here, by pre-multiplying, the process is like so. Okay, so what we need to do is, it's all about the ones. Okay, so I'm just going to highlight the ones in the permutation matrix. The ones are the important ones in this concept. So in terms of the position of those ones, the position of the first one is in position row 1, column 2. That's the first one. So the first one is in position 1, 2, and I used a lowercase d to represent that it's in matrix D. So that's sort of the way in which we write the position of the elements. So it's in position D, 1, 2. Now some people write a comma between the 1 and the 2, but you don't need to. So now you might say, well, what do we actually do with that? Okay, so what we do with that is we actually reverse the 1 and the 2, which I've just hidden there. Sorry, just highlighted, not hidden, just highlighted. So what we do there is we reverse the 1 and the 2 to then give us 2 and 1, which again, I will highlight. And you might say, well, okay, that's fine. And what do I do with the 2, 1? Or is it 21? Or what do we do there? Okay, so what we do is, because it's 2, 1, we find what the second row was in matrix C, and we move that to the first position of the answer matrix. I'll say that again. So your answer matrix is going to be there. So because we highlighted the 2, 1, okay, we find what was the second position, which is the O, and then we move that to position 1. So essentially, it's almost like a little map. It's telling you what to move where. Now let's go through the next one. It's okay if that sort of went a little bit over your head, because hopefully after the next couple, it'll make a little bit more sense. So now, once again, we locate the next one in the permutation matrix. So the next one is in position 2, 3, because it's in the second row and in the third column. So once again, Again, you don't need to highlight, but I'm just highlighting just for this example. So then what we do, we flip the 2 and the 3, and we then make it into 3, 2. So then what do we do with that? Well, then we take the third row, whatever was in the third row, and we move it to the second row. So in this example, the L is in the third row, so that way it moves from position 3, it now goes to position 2. So then the L goes there. Now we obviously know the B is going to go in the third place, but let's see how it actually gets there. So we've now got our final one to look at in our permutation matrix, and it's in position 3, 1 because it's in the third row in the first column. So now once again we flip those numbers to give us 1, 3. So then we go back to our original matrix, which is matrix C, and we say, all right, well, what was in position 1? Well, the B was, and now we're going to move it to position 3. So that was in position 1, we're now going to move it to position 3. And there we have it. We have rearranged the column matrix from saying BOL, and it now says OLB. Okay, now that's quite a simple example because it's sort of only a 3 by 3 matrix, but you can get a permutation matrix that's 4 by 4 and bigger. Okay, but generally probably the most common ones you're going to see are 3 by 3s and 4 by 4s. But if not, you just follow that process. Now the process for post multiplying is a little bit simpler, which we'll see in the next part of the video. All right, now just like we did for the pre-multiplying example, let's have a look at this one here. So we've got apply the permutation matrix by multiplying matrix C and matrix D. Okay, so once again, it's got post multiplying, so we know we're going to post multiply, but let's work out why. So we've got matrix C, which is a row matrix consisting of 4 columns, and then we've got matrix D, which is a square binary matrix, which is your permutation matrix, which is a 4 by 4. So let's just see, if we weren't sure, let's try multiply C and D. So we now have matrix C, we write down the order is a 1 by 4, and then matrix D is a 4 by 4. Okay, now you'll see those two middle numbers are equal or the same, so therefore that is the order in which. Now if we flip that, the middle two values will be a 1 and a 4, so therefore we can't do that. So that's telling you that you need to post multiply by the permutation matrix. All right, so I've just written out that it must be C multiplied by D. So what we need to do now, once again, in the permutation matrix, the most important elements are all the ones, and they're the ones that we're going to focus on, just like we did in the previous question. So, like I also said before, the post multiplying is a little bit simpler because we don't sort of need to do that flip like we did previously. So let's locate the first one, which is this one here. Okay, so what we do is that element is D12. Now, like we did before, if we were pre-multiplying, we would flip the 1 to 2, which would make 2, 1. But when we're post-multiplying, we don't need to do that. So what we do with the 1 and the 2 as they are, we go back to our original matrix, which is the one that says play, matrix C, and we see, okay, so position 1, whatever was in position 1, is now going to move to position 2. So I'll just have my matrix here. So position 1 was P, it's now going to move to position 2. Then we look at where's the next one. Well, that's the next one there, and that position is now in D, row 2, column 4. So then now we go back to our original, matrix. I'll just rub that one out. We go back to our original matrix and we say, okay, well, what was in the second position? Whatever it was in the second column, it's going to now move to the 4th column. So what was in our second column was L, and it's now going to move to the 4th column and take in the place of Y. So then in our answer, L is going to then be in column 4. And then we do the same thing for the other ones in the permutation matrix. So now this one is in position 3, 1 because it's in the third row, first column. So then now once again, we go back to our original matrix C and we see, okay, well, what was in the third column in position 3? I'll just highlight that. And then what was in position 3? Well, position 3 was our A. We're now going to pick it up and shift it into position 1. So there in our answer, the A then goes into position 1. And then our final one that we need to look at is this one here, which is in position 4 and 3, because it's in the fourth row and the third column. So then now, once again, we locate whatever was in the fourth position, the fourth column in your row matrix. And then we say, okay, well, that was in the fourth position. The Y was in the fourth position. And therefore, we need to pick it up and move it into the third position, which is the only only empty slot in our answer matrix. So the Y is then going to be there. So we have gone from the row matrix saying play, so P-L-A-Y, and then we have rearranged all of the elements in there to give us the matrix of A, P, Y, and L. All right, now let's have a go at finding the permutation matrix. So in all the examples so far, we've been given the permutation matrix and then sort of been challenged to either pre or post multiply based on if it's a row or column matrix. So now this one's a little bit different. So it says find the permutation matrix, which is P, if it has been multiplied with matrix X to produce matrix Y. Okay, so what we do, so matrix P is multiplying matrix X, but we need to work out whether it's X times P or P times X. The easiest way to do it is matrix X is a row matrix. We'll just circle it here. It's a row matrix, which means it consists of only one row and in this case 4 columns. So therefore, if we have a row matrix, we need to change the columns, which we would need to change a column R, column A, column I, column N, or maybe not all of them, but some of them. We then need to post multiply by the permutation matrix. So in this case, it's going to be X times P is equal to Y. So we've got X, we've got Y, we just need to find P. Now, because matrix X is a 1 by 4, we hopefully know that the permutation matrix is going to be a 4 by 4 matrix. So what I'm going to do, I'll just set up a 4 by 4 matrix and we'll leave it blank and we'll fill it out in terms of what needs to go in there in terms of the zeros and the ones. Okay, so I've just drawn up a 4 by 4 matrix and I've just put some sort of lines underneath just so we sort of can see that there should be 16 elements, 4 rows and 4 columns. Okay, so now what we need to do, now normally we would look for the ones and then sort of find the ones and then sort of see, okay, well, where are the ones, what position are they in? But we don't have the permutation matrix. So we need to go back to X and Y, matrix X and Y, and sort of see, well, where did the elements move to and from? So in this case, element R moved from here to here. Hopefully we can all agree and follow that. So it moved from position 1 to position 3. So it moved from column 1 to column 3. So that means in my permutation matrix, I must have a 1 in row 1 and column 3. So that means my 1 goes there. Now we start again. And then we say, okay, well, I've done R. Now let's find A. So A went from here to here. It went from position 2, column 2, into column 1 or position 1. So that means in my permutation matrix, there must be a 1 in row 2, column 1, which is in this position here. And then we put a 1 there. And then we keep going and we find for I and for N. So now we go to the I and we say, okay, well, the I was there and then it went there. So it was in position 3, which is in the third column, and then it went into the second column in the answer. So therefore, we need to have a 1 in row 3, column 2, which is that position there. And then finally, well, where did N move to and from? Well, N's gone from here to here. Okay, it's a dodgy little arrow I've just drawn there. So you'll see N has gone from column 4 to column 4. So it hasn't actually moved. Okay, so that now signifies that there must be a 1 in row 4, column 4, which is this one here. Now you'll see, is there only one singular 1 in every row and every column? Yes. So as soon as you do that, we know in a permutation matrix the rest of the values must be 0, so we can simply just fill out all the other elements in the permutation matrix as being 0. And there's our permutation matrix. So now to double check, what we could do is we could simply just do this equation here. So we could simply just put into our CAS calculator or do manually by hand x times p, and we should get y, which in this case we do. So that is how we find the missing permutation matrix if we have two matrices, sort of like the question and the answer, in this case x and y. So the last part of the video is just to sort of see the relationship or the association between a permutation matrix and the identity matrix. So if you don't have sort of an in-depth understanding about the identity matrix, feel free to check out my video on the identity matrix, because this sort of part of the video won't make a lot of sense to you if you don't have that base understanding about what the identity matrix is. So the identity matrix is a permutation matrix, as it's a square matrix consisting of only ones and zeros, with there being only a single 1 in each row and each column, with the rest of the values being a 0, which we've spoken about previously. The special thing about the identity matrix is that when you pre or post multiply a matrix by the identity matrix, there'll be no change to the elements in the existing matrix. So for example, if we have a look, we've got matrix C, and then we have matrix I. So matrix I is the identity matrix because the ones are all in the leading diagonal, which means they go from the element in the top left to the bottom right. And then we've got matrix C. So as we've seen before, matrix I is a permutation matrix, so we would need to apply it in terms of our pre and post. Okay, but like we said, the special thing about the identity matrix is that whether we pre or post multiply matrix C by the identity matrix, you will end up just getting matrix C. So that's sort of the special thing to do with the identity matrix. There'll be no change to the original or the existing matrix. Thanks again for watching another video brought to you by RouTube. Now, as the end of Unit 4 is fast approaching, if you feel like someone may benefit from watching that video, please feel free to share it with your classmates and or your friends from another school, or they might be in another further maths class. Obviously, please feel free to share that with them. And most importantly, please feel free to like and subscribe to my channel. And as always, as we approach the exams, I'm going to be looking at uploading some more videos. So please feel free to jump on and check out my new videos that will be coming up in the next week or two.